Hi, podcast listeners. Today's episode is a best-of compilation pulled from the Fine Homebuilding podcast archives. Thanks for listening. We'll be back next week with a brand new episode. Enjoy. This is Senior Editor Patrick McComb. I'm joined by Associate Editor Matt Milham.
Hi.
And Rob Watzak, Digital Brand Manager.
Howdy.
All right, so we heard from a number of folks this week, and number one is Eric Turner from Asheville, North Carolina. You guys ever been to Asheville?
I don't think so.
Never been up into the hills there. Here it's nice.
So beautiful. I'm blessed I get to travel a lot for my job, and Asheville is one of the places I could really see myself living. It is absolutely beautiful in the mountains of North Carolina, temperate climate, beautiful scenery, lovely place.
Here there are a lot of creative people living out there. Right?
Yes, and it's a booming, and it's also a hotbed of brewing. A couple of big breweries have facilities there.
Yeah, hipster haven, I imagine.
Oh, I can't wait. I'm ready. Eric writes, I own a 120-year-old farmhouse in farm country outside of Asheville, North Carolina that has had a few additions over the years. The oldest areas of the house do not have any insulation in the walls at all. You can feel the wind across the entire front of the house. We're removing the original beat-up beadboard and putting up nickel gap shiplap in its place. So I figured this would be a good opportunity to insulate. The walls are true 2x4 studs, full inches thick. The exterior sheathing, he puts in quotes sheathing, is the original board and batten running vertically, approximately 10 inches wide with 1-inch thick boards with a significant gap between each of them. Then there are layers of asphalt siding followed by aluminum siding. Question 1. Even though the gaps between the boards are covered by wood strips on the exterior, should I fill those gaps with an expanding foam like Great Stuff? I suspect the gaps are where most of the wind is getting through. All right, so we take that first one.
So from the photo, it looks like he's already gotten started on that.
He did. He says, and I don't know if it was in this email or a subsequent one, that he started doing this and then wondered if it was a good idea.
Now, I don't think it's a bad idea necessarily. I mean, the fact that there are battens on the other side is helpful. Don't know if the Great Stuff foam is the perfect material for the job, because the one thing is with those he's got basically big wide planks on the whole front of his house.
And in the summer, those boards are going to swell in this climate.
And that's one of the biggest concerns with using that sort of material as air sealing, is that if there's a lot of movement in the wood, that it could eventually open up.
Yeah, will it actually seal it long term?
So I know some of the foams that are out now are claimed to be stickier and stretchier. I don't really know a whole lot about it, but you might consider a flexible caulk, but that's an awful lot of cracks to be caulking.
You could also use an air sealing tape, but that's very expensive.
Do you know, is there any product still around? I know Owens Corning had a while back some sort of spray air sealing thing. It was made mostly for people who are doing the sort of flash and bat that didn't want to add spray foam.
Yeah, so Owens Corning and Knauf both have like liquid caulking systems meant to be used with fiberglass bats, and I think that's a pretty good suggestion. I would also want to try, Dow has been making a foam product for airtight drywall approach. It's meant to go on the face of the studs. You let it harden, and then when you put the panels on, it creates this gasket. And the idea with this stuff is it's meant to be more elastic than most spray foams. So that might be a good application for this, but that's kind of an off-label recommendation. I don't know what Dow would say about that.
Now, I was poking around on Green Building Advisors forum and found somebody talking about insulating an old house that didn't have sheathing, sort of similar situation, a leaky exterior wall, and they were tearing off the interior, similar to this. And, a lot of people actually recommended dense pack cellulose. And now if he's putting board paneling on the inside, you'd think, oh, well, then he's got to drill some holes in the boards. But what a lot of people recommend, and what you see a lot in Europe, is interior air barriers. Whether you do it out of something like OSB and
but what about wetting from the gaps in the boards, soaking that cellulose?
To tell you the truth, as long as the flashing details were good on the outside, nobody seemed to be that worried about it. And we're talking about some of the top people that seem to respond to those questions.
Well, those top people I got an issue with because this house has board and batten siding, which means there's no lapping to stop water, to control water, right? And especially at the tops of windows, my guess is that these boards are rotten.
Yeah.
Except that he's got like other layers of siding over the board and batten, so it sounds like.
I think that's going to be an interesting component of this particular stack up.
Yeah.
So he's got this asphalt siding, and once again, where I grew up, this was a kind of a popular thing.
Sometimes
it's
it
like a
look
fiberboard with asphalt layer and then like granules like that would be on roofing shingles, right? And they either meant to look like stone or brick. It's never convincing.
Yeah.
It looks like Enso brick. And then they have aluminum siding on this thing, which is water shedding, right?
Sure. So I mean, obviously, you want to be sure that you have some flashing details in place if you're going to have cellulose inside your walls, but regardless of what insulation they use in the walls, an interior air barrier might not be a bad idea.
Under his nickel gap paneling.
Yeah, there's one product that some people are recommending. There's that company, I think based in Brooklyn, 475, that provides a lot of air sealing materials, a lot of building science, high performance building materials. And there's this material called Intello Plus, which it's basically a fabric of some sort, almost like a house wrap, but that they use for interior air barriers and as a substrate to blow cellulose insulation through. So that's something to consider. Because, a lot of people put up, like you see those old cathedral ceilings that people do in cabins where they do the boards and they just skip the drywall altogether.
Bad idea.
And they've got no air barrier, and then in the winter it basically rains from their
because the warm,
ceilings.
moist air from the inside is condensing up on the sheathing or the framing members up in the ceiling and then dripping down.
Yeah, so I mean, if he's got leaky exterior wall surfaces, putting just the nickel gapped boards on the inside is certainly not going to be a good enough air barrier.
I'm going to make another suggestion here too, and I don't think the foam is necessarily a bad idea. I agree with Rob that expansion and contraction over time could make it fail. But on the interior of the board sheathing, I think I would put a layer of 30-pound felt stapled to the sides of the studs and the bottom plate and the top plate to kind of make a what would that be, a 5-sided box, and that would keep the water from coming into the insulation cavity. It's going to help with the air barrier consideration. And then, I think it's a bad practice to put board siding on the interior of a heated or conditioned space.
As the only
surface. I think we need something. Rob suggests one of these air barriers. Or European air barrier, we call them generically.
Yep. I think they're made in Germany. But, a lot of times, I know that some of the folks at the Passive Housing Institute US did a bunch of houses where I think they literally just did OSB taped.
Yep, I think that would work great.
Yep.
Thermoply is another option, which is a very thin cardboard material with kind of a shiny surface that's meant to be an air barrier that's commonly used behind shower units and that kind of stuff. That's inexpensive, but any of these things you have to tape and detail so that air is not getting from the inside to the outside, I think, is the key.
Yeah.
Yep.
What would you do?
I'd take the siding off and I'd put rigid foam on the outside. And I'd tape all those seams.
Yeah. I asked Eric in a subsequent email if he was planning to reside in the near future or wherever, and that would definitely, I didn't hear back from him, that would definitely affect what I would tell him to do.
Yeah, and also just knowing how big of a part of this house we're talking about. I mean, if it's a small wing of the house, the extra labor involved in tearing that board off and putting it back on or putting something else back on might just be worth it.
Yeah. His next question. How should I fill the wall cavity? Since insulation in the big box doors are made for either 2x4 or 2x6 dimensional lumber and mine are in between, should I go with foam, 1/2 inches of foam followed by standard 2x4 insulation? Or should I just use 2x6 insulation or just 2x4? I would say use 2x6 insulation. You're not going to get the R21 R value that's on the package, but a chart I looked at, and that'll be on the podcast page for this episode. I think you get a R19 or R16 with an R21 bat and a 4-inch cavity. Yeah, you're going to lose. I mean, if you're only compressing something about an inch like that, you're going to lose maybe a couple of R value. But like you said, it's better. If you put too thin a layer in there, you're not going to have the stated R value of that either, and it's going to perform much worse. So there's no harm
in compressing fiberglass bats.
To a point, right? You don't want it to affect how your drywall goes on or what have you, right?
Sure.
It needs to be a reasonable amount. But yeah, 2x6 in a 4-inch cavity, not a problem at all. He asked, are there any moisture airflow issues that I should look out for when insulating a wall this old? Yeah, you got to keep the water out, and you got to have an air barrier on one side or the other, and both is best. So, Eric, let us know how things go there. I hope you're enjoying your home in Asheville. Maybe we'll be neighbors someday. This is purely for my own indulgence, this question here. So I saw this on a Facebook page for professional builders that I follow, and the question was, what are the tools you've bought where you immediately thought, I can't believe I've waited so long? So I'm asking you guys, what are the tools that you have purchased that have changed your life and you said to yourself, man, I should have got this a long time ago?
I don't know that anything necessarily changed my life, but
I don't think you're living right then.
Anything sort of battery operated. Like I remember when I first started in building, I guess, and it was like my second building job. They were like, you have to have a good circ saw and a Sawzall. So I didn't have. I had a terrible circ saw and I had no Sawzall. So I went out and I bought corded versions. I bought a corded Makita and a corded Milwaukee Sawzall.
Ooh.
And the Sawzall I used like once or twice, but in the like probably the first month or whatever that I had that circ saw, I never used it, not once. And then mostly because there just aren't cords lying around, and another guy on the job site had one of the cordless
But
Milwaukee
why didn't you use
saws.
it prior? I got to ask.
Why didn't I use the
circ saw?
The circ saw? Just because another guy on the job site had a battery-operated Milwaukee saw.
So you'd use his.
So we just, that was
Okay.
available. And, rather than go try to track down a cord,
Sure.
we just use that. So I ended up, they went on sale, and I bought the battery versions of both the Sawzall and the circ saw, and I still have not used that Makita, not once. I've had it for 2 years now, more than 2 years, and I haven't used it one time.
A cordless circular saw is an amazing thing.
Yeah.
I'll let you answer before I dive into this.
One of my favorite tools that I have, and the funny thing is when this type of tool first came out, I hated them, is those little cordless impact drivers.
Why did you hate it?
Because
the noise.
Because I had this beefy, rigid 18-volt drill back then, and I could drive screws all day long with that thing, and it was not noisy, and it was not shaking my hands to pieces. And so when people started bringing those impact drivers on the job site, I was like, oh my God, these things, it's like a swarm of bees, wasps, buzzing around your head. But when
was this, Rob?
How long ago did they first came out? No. I mean, that was quite a few years ago but anyway, then I got a hold of that Hitachi with the little electronic clutch on it that has the 4 different positions for self-tapping screws, for normal screws, for bigger screws, and for large fasteners. And the fact that you can just drive a 1/2-inch bolt in with that thing is just amazing.
It's so awesome.
And so it's like I will use screws even sometimes when nails seem like they might be easier just to use that tool because it's so powerful. But one other tool, I have the PLS 180 laser level.
Yeah, that was a popular tool for this group to identify, or lasers generally, and specifically that one.
When I was working in remodeling, the only lasers that were available were those big
Why don't you tell
rotary
folks
ones.
what that is?
Okay,
PLS, you have
So the PLS 180 is a 180-degree line laser level that draws a crosshair of lines for getting plumb and level when you're laying cabinetry.
And it's about the size of a tape measure, right?
Yeah, like one of those Fat Max tape measures. It's almost exactly the same size, and so you could.
And it's self-leveling.
It's got a little fulcrum inside that it with some weights that it self-levels. A pendulum, yeah. And I used it I was remodeling my attic a bunch of years ago, and my roof in this 1870s house is just all wonky all over the place, and I wanted to put a flat ceiling on it. And so basically you're running little short collar tie type ceiling joists along the whole ceiling. I just screwed a block of wood to one end of the room and just worked my way from the far end of the room back and got this perfectly flat ceiling. It would have been impossible with this. I mean, it wouldn't have been possible. I mean, I've laid out entire floors in gutted 200-year-old houses with an 8-foot or 6-foot level before, and it's hell.
Yeah. And that tool costs what, a few $100, $200?
Yeah, I'll put the price in the link in our podcast.
And they have ones
notes.
that also do like layout 90 degree and have a dot laser, and I think that's called the 720 or something. They have another version that does more things, but yeah, everyone loves that tool because it's awesome, no doubt about it. I can tell you that I was very skeptical of oscillating multi-tools, what people call a fine tool, or my favorite thing I've heard it described was a buzzy tool. With some deck builders in New Hampshire called it the buzzy tool, which I thought was funny. But you know, it's a motor with a blade that oscillates back and forth, like the thing that they use to cut casts off of people. And forgive me if you all have heard about this out there, but for those of you who haven't, it is an indispensable remodeling tool. And now they're very affordable. They used to be made by one company, Fine, and they were, I think the prices started at $300, but now you can buy one for $1.50. 150, I mean. Yeah,
when that was on my list too. When the Fine tool first came out, a couple of years in, I bought one when their cheap model was, I think, like $230. And I was on a job site with a couple other former Fine Homebuilding guys, and there was a deck that had already been decked, and they had to add posts. And so the decking boards were there, and the framing was inset from the side of the post. And I was like, how the heck are we going to get these holes clean cut fast? And so like that night I went and bought one, and the next day brought it to the job.
So they brought this, they knew about this, or this was your solution to
this was my solution. I was like, I'm getting the right tool for this job, and it's just been an indispensable tool. I mean, the three main reasons are cutting holes, whether it be for like a electrical box in a cabinet, or if you're installing cabinetry or flooring to trim flush to jambs or baseboards. You just hold up a block of wood to the wall and you just get a straight line. And
otherwise, you'd have to like pull that off, cut it, and then put it back, right?
But so I had the Fine one for years, and it did its thing. But it was over the years, it got to be a pain with the little Allen bolt to get the tool, the blade out, and then I finally broke down recently and bought one of the DeWalt cordless ones, and it's so much more powerful, and you just flip a little switch and the blade pops right out, which is so nice.
Well, interesting. So people ask us all the time about Harbor Freight tools, and the one that I see a lot of on the job site is their Oscillating Multi-Tool, which costs like $20.
Man.
And I've had people tell me that they've had them for years. So if you're hesitant to spend a bunch of money, I've seen a bunch of those out there.
I've got a Makita corded one, and I like it fine, but that's another one of those things where I bought a corded tool and immediately wished that I had just spent a little more money and got the cordless. And yesterday, actually, I saw a big box store had the M12 version of the Milwaukee one, and one of their little M12 drivers for sale. I think it was 2 batteries, maybe it was just 1 battery for like $99 for both of those. And I had a really hard time not buying them. I'm like, I don't need it.
I don't know. That'd be fun to have. Yeah. So those of you out there who are listening who have a favorite tool that was quite a life-changing experience, if you want to write in and tell us about that, I'd love to hear about it. I'm sure there are many others that are equally useful in my history, but cordless anything and the Oscillating Multi-Tool have definitely improved my life, as has my little line laser.
Yep.
Totally.
Yeah.
All right. Lloyd Brown from Utah writes, great discussion in episode 142 about resources for building houses that are resilient in the face of hurricane, storm surge, etc. This has sparked a lot of interest, right? Because it's fascinating.
Yeah.
Where I live in central Utah, we're extremely close to a major seismic fault line and have been warned for years about being overdue for a big earthquake, though, of course, it's impossible to predict when that would happen. So here's the question. If you were building a new home in an earthquake zone like this, what would you do to try to minimize the damage from a significant quake? Are there learning resources beyond FEMA and the IBHS, Institute for Business and Home Safety? Did I get that right this time?
I think that's right.
Right. Thanks and keep up the good work. Okay, so what do we say about this?
We
did gloss over the entire seismic concerns with resilience, didn't we?
It really drives home that how regional your concerns are. I mean, thinking about the attic fan in the previous question, and thinking about seismic concerns, these things really, it's like you forget that people have to worry about all these different things that you don't in your own backyard.
I believe me, I know. Yeah, so I do know a little bit about this, but not all that much.
Yeah, same. And I mean, as far as like trying to find resources, FEMA does have a pretty good document. I think you included in your notes, but
well, actually, Lloyd did.
Yeah. Well, that's about all.
Lloyd, thank you for doing our homework.
Yeah. I mean, I did see some other things out there, but as far as like widespread recommendations, on par with what IBHS is doing, I didn't see anything.
So
like
I know
that.
A few things. Wood frame construction is way more
resilient
in seismic events
Sure,
because it can move.
The key physics concern here is inertia. If you've got something that's massive and or brittle, it's at risk. You'd think that concrete would be stronger than wood, but no. If the ground is moving abruptly beneath it, you want something that can move quickly with it. And the lighter the structure and the more rigid the structure is what you're really looking for. But also what a lot of people find is it doesn't necessarily want to be as connected to the ground as you would think.
Well, but you want all the elements of the house very well connected together. Foundation connections are key.
Can be.
Yeah.
Because there are a lot of different strategies for dealing with this. So like in some designs, they want the sort of like the house to move sort of independently of the ground.
Yes.
So, it basically just slides around on top of it, on top of ball bearings or some, sort of similar strategies, shock absorbers, whatever. But yeah, I mean, there's so many different kinds of movement associated with earthquakes, and then you have all the other kinds of natural disasters that can come along too.
I mean, again, it's probably even a regional concern because depending on the type of fault line you're on, different seismic regions get different soil conditions. Different seismic regions have different concerns. But
the thing is, you want the house to stay on the foundation, right? That's one of the key components. You want levels to be well connected together so they don't shear apart when the thing starts shaking.
Yeah, build low.
Build low and small, right? Larger, longer buildings are more susceptible to seismic forces than shorter and more compact structures, right? Like Rob said, mass is everything. You want low mass roofing, light roofing materials, concrete tile and clay tile, which are traditional choices in Southern California, are probably a really bad idea because you have so much mass on the top of the house. When it starts shaking, things come apart.
Yeah.
And to Matt's earlier point about some people think that maybe the house should move and not be connected to the foundation. Whenever I look things like this up, I always seem to stumble upon engineering university students' research projects on similar topics. And so Stanford University, I'll put a link to this. You got to watch this video of this house that they built to test this system that they were thinking would work really well. And
so briefly, what is their system?
So they built a system, and apparently in California there are buildings, even big commercial and municipal buildings, that use similar devices. And what it is it's metal plates with plastic bushings between them, and it's probably something like high-density polyethylene, the same kind of stuff you see as bushings in a lot of woodworking tools. And they built this table that they call the shake table, and this thing can move several feet in any direction very quickly. And they built this house with stucco walls, stucco exterior
just
on
to
it.
demonstrate that it was unaffected by the shaking.
Well, also because in the region that
That's
are,
what you
stucco
do.
is a common material. So they're like, how can we build houses the way we already build them here, but to withstand these forces? And so you got to watch this video because it's the house is violently being coaxed to move around, and because of these plates that it's sitting on, it's able to let inertia keep the house roughly right where it was standing when the earthquake started. But they were using this to test their strategies. And so what they came up with is they use more massive or more rigid drywall on the inside. They use 5/8 on the walls as well as the ceiling, and they use adhesive to glue it in addition to screws. And on the exterior, they use more screws than they would typically use to fasten an even stronger mesh that's the substrate for the stucco, and that was resisting cracking
Cool.
in the stucco. And the thing is, a lot of these strategies also pair up well with a lot of the air sealing strategies, and like the adhesive on the drywall. There's the idea of airtight drywall to get better cavity seals around fibrous or blown-in insulation. And so, you're sort of killing two birds with one stone there if you've got your drywall adhered to the wall completely.
Totally.
Making future remodels almost impossible.
Yeah, same thing with spray foam, all those things. Yeah. Well, you got to, what are the trade-offs?
Yeah, yeah.
Some other things you want to do in seismic areas, you want to make sure your water heater is secured to the framing because they fall over. Same with other appliances. I would be really worried about the high boy furniture loaded with dishes and stuff. I would make sure that thing was tied to the wall. And that's easy stuff that you can fix yourself, right?
Yeah, it's funny. I've got a friend out in California who's lives in it. He's lived through a fair amount of earthquakes out there, and I'd given him a present one year, one of those double-end cross-cut saws that the loggers would have used, because he was a wood science major, and he had that thing screwed to the wall in his bedroom above his bed, and he woke up in the middle of an earthquake one day, and he was just, it didn't fall in, but that was fasten things down.
Yeah, it's fasten things down. The other big problem is, the code calls them silly stuff, but garage portals, which are garage doors, and the concern is that they often have these very narrow walls on the sides of them that support the rest of the structure above, and those are very susceptible to overturning because they're narrow. So oftentimes, in new builds, if you have an internal garage, you use a moment frame or these engineered panels that are meant to resist that overturning force.
Yeah.
That's important in high winds too.
Sure.
Yeah, a lot of the forces are the same. So you're addressing two things at once with a lot of these solutions.
So I was in Charleston, South Carolina a few years ago, and I didn't realize at the time, I'm sure most people don't, but that is a very seismically active area. So that part of the country, the West Coast, the section of Utah and Nevada, upstate New York, all these places, I was looking on the code map, and like a lot of things, the code book has risk zones for seismic areas. So you can look up your own area and see how much you have to worry about this. And there are prescriptive methods for building in these areas, depending on how big the structure is and how tall it is and what it's clad with. And you can build a pretty resistant structure based solely on what's in the code books now.
Good to know.
Yeah.
Is this Nate?
Yeah, Nate.
All right. Hey guys, my wife and I love old houses. Our first home was a single-story 1915 Craftsman that had already been renovated. We are looking at selling that home and purchasing what appears to be a late 1800s two-story. I'm confident, maybe overly confident, in my renovation abilities, but would like your advice. What should I look for when purchasing an old house? The trim profiles are really shallow, so I'm assuming that the plaster was covered with drywall at some point. The floors aren't level, and in one location, the floor drops about 1.5 to 2 inches over about 3 feet.
That is a lot.
Yeah. It's called a bathtub. There is some rot below a toilet that I can see in the crawl space, but it's not so much that it's visible, or not so much the visible things that scare me. Any advice that you have on purchasing an old house would be greatly appreciated. And then he sent some pictures.
Yeah, let's have a look.
Yeah. Yeah, you can't really see water damage under that toilet from above.
I mean, the pictures he sent,
that looks pretty raunchy.
In the basement, you're going to find some punky stuff sometimes. But overall, the pictures of this house look pretty nice. I mean, but of course, we're only seeing a little tiny bit of the house. We're not seeing.
There's
the whole
nothing
thing.
going on good there, I'll tell you.
Yeah.
So that is where an eave butts up against the main part of the house. Looks like an L or some kind of addition, and there's no kick-out flashing. That's probably a detail we should put on the webpage for the show. And the idea is to get the water that's coming down the roof to away from the main building.
Mm-hmm.
But now his question was, where should he be looking at the things that he can't see so well? And we actually have a video series. John Ross, who used to be an editor here, had a guy come. It was George Nash, who's a local restoration specialist and did a whole video series that's on Fine Homebuilding. I'll put a link to it in the podcast notes on inspecting old homes. And a couple of the takeaways from the video series were basically, roof and your foundation are the most important things.
Yeah, I always go to the basement first. That's where the expensive stuff is, right?
Yeah, you look for moisture issues, look for crumbling stone foundation, look at the walls and look at all the surfaces and see if there's anything that just looks really out of whack, out of plumb.
And I would look at the heating and plumbing systems too, because that's going to be thousands of dollars if they go south.
Sure, and if a house is that old, I'm sure it has just bits and pieces of every era of electrical wiring.
Yeah, it's also an issue.
So try to find out if all the knob and tubes been removed and replaced. But also, I was poking around online and found there's a Historic Building Inspectors Association, and they have listings for people in not every state in the country, but people who specialize in inspecting old homes. And then there's another, if you can't find somebody there's another website I found called preservationdirectory.com, and they will give you, they have lists of links of contact information, not just for specialists, but for your local or regional preservation societies. And, if it's an old home in an area where there are other old homes, there's going to be people that know how those houses are built in that region, and it's probably best to go to a local expert.
Should we address his question built into his bigger question? The trim profiles are really shallow, so I'm assuming that the plaster was covered with drywall at some point. That's a technique I've seen a lot, quarter-inch drywall over existing plaster walls to cover problems or cover holes made from blowing in insulation. It's a shame to have the trim so shallow.
But sometimes in some older homes in certain regions, you will find that they actually trim out all of the openings and then they plaster
to them. Yeah.
So you can't just assume that it's drywall under there. You got to do a little poking around and try to find out, because
a good thing to do is to pull off a light switch cover, and then you might be able to see what the wall, how it's built.
Yeah. Scribing to plaster.
Yeah.
is a really dumb way to do it.
Yeah.
It's a lot easier to put the trim up first and then plaster to that.
I would say, as far as buying old houses, I haven't bought anything nearly this old, but you just got to expect problems, and I'd put some money aside for inevitable things that are going to be wrong with it.
Assume you're going to be cold. They're almost always under insulated because
Sure.
in a house of this era, if it is plastered, then a lot of there's not much cavity to begin with, and there's plaster that's sort of like seeped behind all of that lath. When they were putting it on. So there's not probably a full 4 inches, like this other guy had, to dump whatever they did dump in there at whatever point, and you don't know what it is. If you can find somebody with a thermal camera, go in there when it's cold and just see what the cold spots are, how, maybe it's the whole wall, maybe it's, if they put cellulose in there, maybe like the top 2 feet of every wall is just completely empty and freezing cold now.
If you're really lucky, you'll find one of those old houses in a region where they've actually filled between the timbers with brick before they plaster over their walls. I guess that was to be technique. A thermal mass or something. Do we know exactly what?
I don't know.
Was
thermal mass probably was the idea there, but I've seen it too, and I don't know what it was.
I don't know what that's about either.
Well, I saw a picture where I think like a sill had sort of rotted out, and all of the bricks just fell out of this wall. They were on the ground.
I was called to a project in Vermont when I was living there. A local builder, he knew what I did for a living, so he called me to show me that this entire part of the structure had been built with stacked slab wood, just layer after layer, like stacked from the plate to the rafters, solid walls, solid wood.
The original Legos, pretty much.
I was never seen anything like this. I can only assume that there was a sawmill or something around, and they were just using up the wood they had.
Yeah.
Sure. And on that note, a good friend of mine works in historic preservation down in the Delaware River area in New Jersey, and he was helping work on a project once. It was a commercial, maybe 2-story building in a cute little downtown right on the river, and this building had been built by laying down the sill beams all the way around, and then taking, I think they were something like 2-inch thick planks and just nailing them up as the outside wall. They were just nailed to the side of these beams, and they made
So the sheathing
structure.
was the structure too.
Yeah.
Wow.
Yeah, and to complicate things even more, there was an old stream running underneath the foundation of the building, which had caused some of it to move. And
That sounds like a train wreck.
yeah.
So Larry Hahn in the pages of Fine Homebuilding actually built a shed with that construction method using boards as structure and sheathing. So
Yeah,
we should put a link to that up if anyone's curious what that's about. It seems to be a regional practice. This is my favorite question ever. This is from Ontario. We don't know who.
No.
Okay, that's good.
Jim. Call him Jim.
Jim from Ontario. He's planning to build his own house next year, having gained experience from building a small shed. This is my favorite. That's my favorite part. So he built a shed. Now he's ready for a house. God bless him. For the big house, everything has to be up to code and make the inspector happy, of course. I have some doubts that maybe you guys can help me with. I'm in Ontario, and according to our code, I should be using 2-inch or longer nails for 1/2 or thicker sheathing. I plan to use 1/2-inch plywood. Should I go with a code minimum of 2 or use 2 3/8? No, use 2 3/8 gun nails, right?
Yeah, go. Just
eights.
upgrade to
Eights are
Yeah.
normal.
6s are bare
Short.
minimum.
And that's short.
Yep.
And if you have a nail gun, it doesn't mind that it's 3/8 of an inch longer. So that's easy. I plan to buy hot dip galvanized nails just to make the sheathing look good after raining. I think that's laudable, but I don't know if I would do that. But it can't hurt, right?
Make the sheathing look good after rain.
So he's worried about rust streaks from the nails, right? Messing up his sheathing layer. I don't think I'd worry about that.
No.
For the sheathing layer.
Yeah, it's going to be covered.
Yeah, I mean, if he's just using straight up plywood and he's gonna have to put a WRB or over
I mean, I don't imagine it's going to be that much more money to do that. So if that makes you feel better, I wouldn't worry about it.
Yeah, I mean, basically the questions he's asked so far are: should I do more than the minimum? And if it's not a big deal, that's always a good idea. You know?
Yeah, and I mean, you're going to have trouble finding 6D gun nails anyway. So I would use the 8, 8s anyway. Now for sheathing, I understand that an expansion gap of 1/8 inch has to be left. Do I need to account for this growth when laying out studs 2 feet on center? It doesn't work anymore after a few pieces of siding, right, because they're growing, and the center gets off more and more. So we talked a little bit about this before we came on the air, and I said panels are sized to accommodate for expansion, but you guys say no.
I don't know if it's consistently that. I would have assumed that because like just like in cabinetry, the plywood you use for that, they oversize it because they know you're going to have to
Make
the cuts. But in this situation, they know you're just going to want to slap it up on the wall and not have to make any cuts. So you'd think that it. So I found a post on the Fine Homebuilding Break Time forum where someone was asking the same exact question, and one of the respondents said that, oh, well, if you look at this one particular brand of sheathing, it's typically a little bit less than 48 inches. So in that direction, in the short direction, you don't have to worry about it. But in the length, he said that every third sheet he typically cuts.
Like a 1/4 inch off.
Yeah.
Well, and the other thing is you just move your stud over a little bit, right? But if your cavities are sized for insulation, that can get you into trouble too.
Yeah, it just seems like a silly thing to move the framing when you have so many other things that usually rely on normal framing layouts, like whether it be your siding when you're putting up the siding or cabinetry, drywall, whatever. It just doesn't seem to make any sense to move the framing. I think the sheathing is the time to deal with it. And I'll get to this a little bit more after you ask one of the other questions in here.
So I would say when you get your stack of sheathing, measure it and see if you need to do that. You're going to have to make some accommodation for that expansion gap. And the gap is a good idea.
Yeah. Zip is self-spacing on the long edges. So if you install that vertically, then you won't have
But
an issue.
you should install sheathing horizontally from a structural standpoint.
Yeah. Well, as long as you're blocking, between those courses, and nobody does that.
I don't think you need to do that. I mean, there's some assemblies that require that, but
Yeah.
nobody does that.
Yeah, but I think I can't remember. Like there have been studies on this. Like if you go vertical and you nail off around the entire perimeter and in the field, then it's, I think, as strong or maybe stronger than if you go horizontal and don't block. But if you go horizontal and block, that's the strongest. Yeah.
So go horizontal.
And just cut every third sheet.
I mean, it doesn't.
Well,
Go ahead.
No, go ahead on to the next question.
All right,
about
so, what does this say here? Now for the sheathing. Okay. So should I sheathe the wall first and then raise it, or the other way around? So absolutely sheathe your walls while they're lying down, I would say. And I would let it overhang the bottom plate so it ties into the floor system below, right? Yep. So you're going to have to figure that out. And it does two things. First, it allows you to square the wall panel, right? Because you can use the plywood to do that. And holding sheathing on the side of a house and nailing it is really hard. I've done it. It's hard.
Yeah, if that stuff isn't perfectly flat and then you're trying to wrestle this slightly bowed sheathing vertically, it's a huge pain in the butt.
And plywood has a greater tendency to get bowed than OSB. So if you're using plywood, I would sheathe no matter what with the walls lying down.
Yeah, because even if you had access to pump jacks or a lift, it doesn't make it any easier to hold that thing up on the wall while you're
so
nailing
slow.
it. Yeah, and this is what I meant. I was waiting till this question to talk about the gaps. Is that if you're sheathing a bunch of walls lying on a deck, it's not really that big a deal
to run the saw down.
Make a quick trim on one if it's not lining up where you want it to line up. So.
Absolutely. And so his concern is that problem is we only have two people. So putting on sheathing first would make the walls hard to lift. Well, make your walls shorter. You don't need to frame and sheathe 30 feet of wall. Do 12 feet. Just do small panels.
Yeah, on our website, we've got a bunch of old videos from Larry Hahn, who's like the
framer guru.
The framing guru. And I was watching one of the videos where he was raising walls after he was framing them on the deck. And granted, he, for some reason, hadn't sheathed these
You
first.
know why? Because in California, and someone's probably going to write into this, that's a separate trade. So you have framers and sheeters come in and put the sheathing on after the frame is put up.
Well, and that comes from, and that probably comes from after the World War II, that big housing boom they had out there, because that's what Larry Hahn got his start in. He was a piece, they got paid by the piece, right? Or
the house.
Yeah, and so it was
the more you could do, the more money you made.
Which is part of the reason why he's such a framing guru, because he was just like, oh, how are we going to do this better? And back then they didn't have all the power tools that we have now, and
they were nailing by hand.
But he showed, there was a couple of cool tips. Like one was, and this is obviously something you're not going to do if you're if you have sheathed first, is that he was bumping up the top plate where it overlapped to the next wall, so they would clear the wall if you were doing the wall in sections when you lifted one. But then would you maybe just add the top plate after? Yeah. And then if you're nervous about lifting a wall, and with only two guys, just put some safety things in place. Tack a brace onto the side before you go to lift it up so that you can quickly nail it into some blocking on the floor, and maybe even screw some blocking off of the side of the house as a sort of a stop.
So it doesn't slip off the floor system as you raise it.
Yeah.
There's a lot of ways to prevent that from happening, but I like that way with the blocks for sure. And
get some wall jacks. I don't know if you can rent them, but you can get some.
You think so?
There's some jacks that are relatively inexpensive, like the
Qualcraft
jacks.
To do a whole wall.
That would allow you to do much longer walls. But I think it's totally acceptable to do 12-foot sections of wall.
Oh yeah,
yeah. So don't sweat that. Oh, and how to sheathe the second floor. Do it the same way the first. Sheathe it with the walls lying
just
down.
Higher up.
And you're going to stand them up.
Yeah, again, if you're nervous about lifting a wall when you're that high off the ground, you tie some ropes, you put some blocking down, you do a couple of things to basically prevent it from going where you don't want it to go.
And if it's like stupidly windy, maybe you don't raise walls that day. Maybe you frame them and raise them all later when it's less windy. That's the risk, is if walls without a roof or floor system on them are even braced or susceptible to wind loading and blowing over. So keep that in mind. All right. Now we're moving to Bemidji, Minnesota. Can we watch this video, Jeff?
Hey guys, my name is Doug. I have a quick question for you involving venting here. Let me climb down into my cellar. So down here in my cellar, as you can see, I have my mechanicals, my water softener, water heater, and my furnace. My gas furnace is vented currently up and out pretty decently. I've got some foil tape on there sealing that. Not really sure how well that foil tape is actually doing. And as you can see, it goes up and out. And the water heater vent, which is also gas, is teeing into that. Now this is where my concern is. The water heater vent currently comes up and out of the top of the water heater, but then it kind of bends down and is sloped downward before it tees into the gas vent for the furnace. And then that combined vent then goes out through an old window opening into an old window well outside, 90s up, and to a vent. So really, I'm wondering if you guys have any advice for me on what I can do here. It's going to be very difficult for me to raise this exit location because there is an obstruction. That's really where the bottom of the siding comes down. And so I'm wondering what else are my options here. Just wondering if you have any input. I really enjoy listening to you guys. Thank you so much.
Doug has a mechanical room underneath his kitchen, it looks like, right?
Yeah, it's a tight access getting down there.
And it's like a ship's ladder to access it. And down there is his furnace with his gas and his gas water heater.
And it's down pretty deep because he was talking about it going out a window well, I believe, the venting for that thing.
Yeah.
Right? Mm-hmm.
And so both of these vent pipes for his furnace and his water heater go into a single outlet. They're combined inside the house, like near the band joist, before they go outside as one larger diameter pipe.
Yeah.
And connecting his water heater to this T is a length of flex duct as a flue pipe. And it doesn't rise up. It actually goes up a little bit and then goes back down in kind of a hump.
Yeah,
right.
Because the height of the appliance was actually higher than the flue exiting the wall. So,
yeah, it's going out through an old window that just looks like it's been plywooded over.
Yeah.
So there's a lot of problems with this assembly.
Mm-hmm. And he recognizes that,
Yeah.
I think. I mean, he recognized at least that sloping down was
So
maybe
a
an
key
issue.
rule of flue pipes is that they always slope up, right? They want to go up, not down. You want to keep the gases out of the house, and you want to keep the moisture in the stream of air that's being exhausted, right?
Mm-hmm. Yeah, and particularly if, I mean, well, we'll touch on this, but basically you don't want two flues joining into one inside a dwelling.
I think that's problem number one, is you shouldn't do this.
Yeah,
they
so
should have their own dedicated flue.
At a minimum, his solution here needs to be to run a new hole out the wall and vent them separately.
Mm-hmm.
Also, this flex vent that is connecting his water heater to the flue pipe is not allowed. It has to be what is described as B vent, which is a double wall pipe, and this flex vent is a no-go, not allowed. So this water heater has a draft inducer motor on the top of it meant to force the gases out, and that's probably the only way this thing has been working at all, right? Because all the other things are working against it. And some of those tight style water heaters use a plastic type pipe, but this one I went and looked because his video showed what manufacturer's water heater he had, which is a Richmond. I believe it's an XR90, which I believe is a 30-gallon gas water heater. And I looked up the instructions for that, and it's supposed to use B vent, and it also says that the connector between the top of the water heater and the vent connection must rise a 1/4 inch for every foot in length. So he's going to have to fix that too. And it might be a matter if he has to buy a shorter water heater, a low boy as they're described, or a mid-height water heater to get the heater low enough that he can actually have some pitch to his outlet.
Yeah.
Yeah. Now, I'm not familiar with this. I was trying to look it up in the code, but you guys are more the code experts than I am. If that's a non-operable window that's been filled in, is that an acceptable way to vent an appliance from a basement?
So you can go out the building and up and terminate, right?
Yeah.
I don't know if there's any special rules that allow you to do that or prevent you from doing that in a window well. It would be more desirable, certainly, to go up without the window well being there, be above it. But I would get a good plumber in there, or definitely read the instructions for your water heater, Doug. I found them on Menard's website. And look at those and get yourself educated on what the installation instructions are, because that's going to guide this whole assembly. There are general rules in the code, but they are superseded by the installation instructions for the particular appliance. In this case, your gas water heater.
Yeah, especially nowadays, since there are so many different ways things are vented. You know, you've got some heaters that have those concentric air intakes, and some are, you know, something like this. These are they're atmospherically vented, right? They're not, or
this one is not. This one has a inducer motor.
Okay. Well, like you said, that's probably what's keeping them safe.
That's what's keeping this from being a CO hazard for sure.
Yeah.
Yeah.
And it's still a CO hazard. It's dangerous. Mm-hmm. And the tape on the flue pipe for the furnace, I don't think that's a legit thing to do either. They do make special sealants for those connections. But once again, I'm not sure that you had the right pipe on there, so I would definitely take a double check on your installation instructions for your furnace, which you can look up online.
Yeah, he had foil tape wrapped around the duct, and that's really intended for duct work for moving air.
Not heated flue gases. Mm-hmm. Yeah. Have you guys seen stuff like this? I totally have.
Oh, yeah.
Yeah.
Oh, yeah.
And, you know, when we used to have houses that were super leaky, it was way less dangerous. But the tighter we make this stuff, like, the stakes are higher.
Yeah, I mean, of course, that's one of the big arguments for the people who are not convinced that houses should be as tight as we are making them is, oh, you're making the house more dangerous. But, you know, if you do your homework and you build the things right and you vent things right, but then again, like you said, there's people out there who have installed stuff. There's probably professionals out there who have installed stuff not up to the proper standards. So, you know, you got to, like you said, do your homework.
Yeah. And I think, you know, even professional installers are guilty of this. You know, oh, I've been installing these for 20 years. I know what I'm doing. Well, stuff changes. You know, it's not the same as it was 20 years ago.
Yep.
Yeah. Code updates, what, every 3 years?
Yeah.
So it's changed a lot.
And, you know, code rules are meant to protect life and property. So, you know, it's not to make your life hard. It's to make people safe.
Yeah. Protect you from yourself.
Yeah.